Hello everyone, today we are going to talk about how to evaluate large language models. And although we may not be able to training on LLMs ourselves, we don't have enough time, we don't have enough resources, but it's interesting to see how we actually train on large language models and also how to evaluate its performance. So let's get started. Basically, firstly, let's look at how we actually train a large language models. So the training basically can be divided into two parts. The first one is to take the large body of text, for example, the internet data or like a book data, Wikipedia page, and Reddit posts, etc. We basically take all these texts and pass it through a large language models and ask the model to predict the next word. And if it is able to predict the next word pretty well, then we can say that this large language model can actually capture the statistics of the language, and also he has a very good understanding of the world models. So the reason why it can form the understanding of the world based only on the prediction of the next token, we can refer to this video 12 about discussion about why AI actually can form its understanding of the external world based on the simple next token prediction tasks. Okay, the second part of the training is about the fine-tuning the pre-trained model so that it can actually be able to answer questions and follow the prompts to generate the test. Okay, so based on that, we can divide the evaluation task into two parts. The first part is to evaluate the next token prediction. So for example, in this case, suppose we have a text x1 to xn, and the cross entropy can be defined as this. So each part is a probability of xi given the previous tokens. So we can take the average of that. That will be the cross entropy for that. And for evaluation, we usually use the perplexity, which is the e to the power of the cross entropy, and which is basically the geometric average of the next token prediction probability. So we can actually interpret the perplexity as this. So if the perplexity is x, which means that the model has 1 over x chance of predicting the next token correctly. So for example, for a good model, x could be as low as 5 to 10. So it may not seem impressive if you think about prediction probability have like 1 over 5 or 1 over 10 correctness. But in reality, considering the vocabulary has a size of like maybe 10,000, so we actually reduce the number of choices from 10,000 all the way to 5 to 10, which is very impressive. So once the model has a very low perplexity, then we can say the model has a pretty good performance in this next token prediction task. Okay, so the second step to evaluate the texture is to evaluate the text generation. So here I show some of the examples of the text generation task. For example, we can do question answering, we can do code generation, we can do text summarization, and also translation. So evaluation basically fall into two different categories. The first one is for results that can be directly verified. For example, for code generation, we can actually verify the results using unit tests. For example, in this case, we can ask the model to generate some text code, and then we can write some unit tests ahead of time such that we can check the generated code against the unit test to see how many tests it actually passed. So that's the way we can actually directly verify the results generated by large language model. But in a lot of cases, the results are more open-ended, so it cannot be verified directly. We have to use some other method. For example, we can use two methods here. The first one is to compare with the reference outputs. The second one is to use AI as a judge. So firstly, we can compare with reference outputs. For example, if we want to translate the sentence, so we can give it a reference outputs, and also we have a bunch of large language model generated outputs. And the thing here is that we don't want to compare the generated output with the reference output word by word, because in a lot of cases they don't have a lot of overlapping words. So what we want to do instead is to compare the semantic meaning. So for example, in this case, we want to convert the reference output and also the generated output into their embeddings. So by embeddings, we basically say that we use a vector to represent this sentence such that this vector captures the semantic meaning of the sentence. So if you're interested, you can refer to the video number 1, which basically basically talk about like what embeddings means in machine learning. And also we talk about how we actually form sentence embeddings in machine learning in video number 8. Okay, so once we have these embeddings for reference output and also generated outputs, we can compare the embeddings to see how similar they are. If they are very similar, then we can say that the LLMs generated good results. Okay, another interesting way to judge the generated output is to use AI as a judge. So basically, if we want to evaluate a output generated by one language model, then we can use another AI with specific prompts to compare the generated output versus reference output. So here's the prompt. For example, we can provide the question and also the reference answer and also generated answer to ask these AI, ask the judge AI to say that whether they are the same or different. And also we can use the judge AI to actually compare two outputs. So for example, if we have two outputs A and B, we can ask the AI to compare these two outputs and say which one is better in this case. So that is another way to actually judge the generated outputs by LLMs. And one thing to note here is that we don't actually need to have a very powerful AI to serve as a judge here, because usually a weaker AI can actually be good enough in this case, because it's easier to evaluate the results than to generate results. So to judge a powerful AI, we can use a like weaker one in here in this evaluation. Okay, that's all I want to talk about, and thank you so much for your attention.